Welcome back. Today we're going to talk about the law of sines. This is in a section that has to do with the law of sines and the law of cosines, but we're just going to talk about the law of sines first. In order to start talking about this, we need to understand that not every triangle is a right triangle. And so when we start to talk about the law of sines and the law of cosines, we're going to be dealing with triangles that are not right triangles. It's important to make that distinction because trig ratios have a greater application than just those 90-degree triangles. And so in example 1, we're going to practice finding the trig ratios of things that are not necessarily acute or 90. They're going to be obtuse angles. And we type them in the same way. I've got my calculator here. I need to make sure that it's in degree mode because remember, we're dealing with degrees here, as you can see me circling. The sine of 135 is going to go into my calculator as sine of 135. So after I put my calculator in degree mode, I do sine of 135 and I get 0.7, and it's nearest hundredth, 0.707, and that's going to be 0.71 when I get done doing my rounding. Alright, so that's how this works. This is actually not really that difficult once we understand degree mode and just plug it in. So when I do tangent of 98, I get minus 7.12. So that's an acceptable answer because remember we know that the tangent is going to give us something kind of bigger normally. And cosine of 108, you get negative 0.31. I got a couple of new things here. I got some negative values. I got some really big values. It's important that we do these to understand that those are acceptable values. Those are things that we can get. Not typical of what we get from a 90-degree triangle, but we can still get those when we're dealing with the trig ratios of larger angles. So why don't you go ahead and try these three in yellow, see what you get, and then we'll talk about those in class. All right? That brings us to our first law, the law of sines. If you'll notice, I've coordinated these things, B and B, A and A, C and C in the colors. The law of sines has to do with a triangle that has this kind of setup. Every triangle could have this setup because we're basically just putting markers to note that angle A is opposite of side A. And the law of sines says this. If I'm going to take the sine of A, whatever A happens to be, A is an angle, and I set up the ratio of sine A over side A, that's going to be equal to the ratio of sine of B over B, and you guessed it, that's going to be equal to the ratio of sine C over C. This gives us a unique setup. Because this relationship exists, and because of the nature of triangles, if an angle's small, then that small angle over this small side over here is going to be the same as the big angle over the big side. We can only use the law of sines in specific situations. It will become clearer which one you're going to use eventually. But for right now, we can use the law of sines if we have, and I'm going to put in parentheses if we're given, two angle measures and any side length. So it would be an angle, angle, side, or angle, side, angle kind of a situation. So if we're given two angles on any side, we can use the law of sines. Also, if we are given two side lengths and a not included angle, just write it out, then we can use it. It would be like a side-side angle situation. Those are the two situations where we can use the law of sines. It will become clear which one you can use pretty handily because the other one's not really going to work. So let's look at what we've got here in a couple of examples. In example 2, we're going to find each measure and we're going to round to the nearest tenth and angle measures to the nearest degree. So in this first part, we're going to try to find DF. Well, this is DF over here. I can just label it X for ease of handling. And notice, I have two angles and a side. And so what we need to do with the law of sines is we need to understand a couple of things. The key to using the law of sines is having an angle and the opposite side. Well, if you look here, I have 105 and the side opposite it. So that's the ratio I'm going to compare to. So the sine of 105 over 18 is going to be my ratio that I'm comparing to because I have the angle and the opposite side. Just like in my setup, sine A over A, well, this is sine of D, and this 18 would be in the place of D. I want DF, and luckily that DF is over this E. So if I say the sine of 32 over X, I am asking for sine of E over what would be little e, but it's got an x in the place. It's df. We're going to try to find that. This works because there's only one missing value. There's only one x. And so if you look at what happens here, I've got a proportion that I can solve here. So I have sine 105 times x equals 18 times sine 32. If I solve for x, I'm going to divide by sine 105, divide by sine 105. So x is equal to 18 times sine 32 over sine of 105. Enter calculator. Make sure we're in degree mode, and I'm going to do 18 times sine 32 and divide that by sine of 105. X is equal to, and I'm rounding the lengths to the nearest tenth, so that's going to be 9.9. So you see how this works. That was a comparison because I was able to use the law of sines because I had the angle and a side opposite of it. Let's look at this next one. If you try to figure out what your comparison ratio is going to be, notice I have 75 and I have 7. So the sine of t, or sine of 75, over the side opposite it, that is going to be my comparison ratio because I have the sine of the angle and I have the opposite side. Well, I'm trying to find measure of angle S. So the sine of S over 5 is what I'm going to be comparing to. Notice how this works. Look, guys, it works like this. You need to have the angle opposite and the side. So the side and the angle that are opposite of one another, those are that's going to make up your ratio. So when I cross multiply these, I have 5 sine 75 is equal to 7 sine of S. I'll divide by 7, divide by 7. So 5 sine 75 divided by 7 equals sine of S. Now, this one's going to involve an extra step. I'm going to use my calculator. 5 sine 75 divided by 7 equals, remember, if I have sine of an angle that I don't know is equal to a decimal, I am going to need to use inverse ratios. because I'm finding an angle. Remember, if I'm finding an angle, I need to use inverse ratios. So I'm actually going to do sine inverse of this decimal over here. And remember, if I do the sine inverse, that's going to give me the angle. So when I find that decimal, I'm going to do the sine inverse of second answer, and that's going to give me nearest degree. So that's going to be equal to 43.6. Okay, you've seen how I've done this twice. I found one side length and one angle measure. If I'm going to be finding the angle, chances are I'm going to be using inverse ratios. So I'm going to scroll down here. You're going to need to pause and try these on your own. Please, guys, try these on your own, because when you come to class and you say, I don't get it, I want you to have tried them so that we can troubleshoot rather than start from scratch. Okay? So I'm going to scroll down. Go ahead and write these down. Here's the first two. We're going to be doing the same thing, finding each measure, rounding lengths to the 10th, and angle measures to the nearest degree. So there's those two. You can also try these two. Once again, same instructions, rounding side length to the nearest 10th, angle measures to the nearest degree. Alright guys, thanks for watching. If you have questions, please, please, please write in the margin. Try those examples. Set up the law of sines. Set them up, and we can help you. Alright? Thanks for watching.